start out with UDP. UDP is a protocol that's used primarily in streaming or real-time communications. And the reason that UDP works best in those types of environments is that UDP is not shackled by a bunch of overhead. And I'm going to explain that in a little bit more detail. At the transport layer, what happens is that communications that is data, which is a large string of bits, and so on. Just imagine how many bits there are in a web page or an email or a streamed movie. And each one of these data segments gets moved down to the transport layer. And at the transport layer, it's broken into segments. And each of these segments gets some port information in the header. So it's from, say, a random port, 5105, as the source. And let's say the destination is a DNS server. So that would be port 53. Each one of these segments is labeled with the source port and the destination port so that they become part of the same conversation. Now, when these actually get transmitted across a network, say like the internet, they may not all go in exactly the same manner. Some of them may get dropped along the way, or they may get put out of order. But in real time, for example, listening to my voice in real time, if we were having an IP phone conversation, if a packet got dropped, we probably wouldn't notice it unless it was a long stream of packets. So basically, for real time, we just allow those packets to take their path from the source to the destination, say the destination is the DNS server, and for the response to return. We aren't all that concerned about a few packets losing their way or getting placed out of order when they're received. Because real time, it's not going to matter because we're not going to go back and pick up those other things and